Hi, now on to our last module, which is density and pressure. So firstly, density is the mass of an object per unit volume, right? So rho is equal to mv, that is the formula, and the unit is kg meter negative cube, right? Because it's in the denominator. Volume is in the denominator. So the thing you need to know about this is how basically how much an object is, how much the mass of an object is compactly placed in unit volume, right? So that's basically density. And pressure is the force applied per unit area, which is P is equal to FA. Now I'm sure that the unit is Pascal, Pascal or short for PA. It's a derived quantity, obviously. So just going to write this here. Now, I'm sure you have a good grasp on the concept of pressure, but I'm still going to give you an example. The example is basically a needle and basically a book that you are holding. Even though the weight of the book is high, the area that is exposed to the hand makes it easier, and basically pressure is basically non-existent. But if you poke yourself with a needle, even just with a little bit of force, area is so low that the pressure becomes high, right? So that's a good example of pressure. And now let's just move on, because I'm sure that you know about pressure and this equation as well, but we are going to derive this one, right? So firstly, you know that pressure is equal to force over A, right? Now, force inside a fluid is basically mg, right? The weight. For example, an object is in water, right? For example, this box in water. The downward force that it's applying is its weight, right? So F is equal to mg here. So P is equal to mg over A. Now you know from the equation of density that density times volume is equal to mass, right? So just plug this into the place of mass here. So this becomes P is equal to rho Vg over A. Now, for example, take the cylinder, for example, right? Its volume is base area, right? A and times H, right? A times H, right? So volume is basically A times H, right? So plug this in here. P is equal to rho A H G over A, and this A cancels out. And so the pressure inside a liquid is rho GH. So that is how this equation is derived. Make sure you memorize this derivation. I know it's a little bit of memorization, but you should know how to derive this equation. Moving on. Now, this equation, right? So what this equation states is, let me just go through the concept first. So whenever you basically suspend an object inside a liquid, it usually comes back up, right? It usually comes back up. So whenever you put a less dense object, an object that is less dense than water, inside the suspended inside the liquid, it comes back up, right? And why does it come back up? Because the pressure, the difference in pressure, basically. And I'm going to tell you how. So the force applied being here is, for example, let's just call this height h1, and let's just call this height h2, right? So the force being applied on this surface is rho g h1, because density in g is the same throughout this. And the force being applied here is rho g h2, right? Now, the forces being applied on these parts are very uniform, right? Because the heights below the surface on these things are equal, right? On all these parts. So this force is equal to this is equal to this is equal to this. So the pressure being applied, the forces cancel out, and no resultant force is basically applied here if the surface is uniform, right? But on the surface, you can see that this value is smaller than this value, right? Just because H2 is larger than H1, right? So what that means is there's a greater pressure. P2, let's just call it P2, is greater than P1, right? So a resultant force is applied upwards and the object goes up, right? And now let's just derive this equation. You know that P is equal to rho GH, and you also know that P is equal to F over A, right? Rho GH, and again, area multiplied by height is volume. So this is the equation. And this is called the Archimedes principle. And I'm just going to write the Archimedes principle here. The force of upthrust is equal to the weight of the liquid displaced. Now, what that means is you can see that rho times V is mass, right? Rho times V is mass. So this just becomes F is equal to mg, and mg refers to the weight of the water, right? Because this density is of water and this volume is the water displayed, right? So basically, if this volume is 50 centimeter cube, so the water will come up 50 centimeter cube, right? So this is the volume of water that is increased, right? So this becomes the weight of the water. So that is what Archimedes' principle suggests, that the force of upthrust is equal to the weight of the liquid displayed. Now, a good thing to know here is some things do not come come up the water, right? When you put it, for example, a steel ball, it will sink down. Why it sink down though? Because the upthrust would be mg of water, right? The weight of water displayed, but the downward force would be the weight of the sphere displaced. Now, the mass in this volume of sphere, right? Because basically this sphere has a density higher than water. Water has a density rho 1, and this has a density rho 2. So rho 2 is higher than rho 1. So what happens is the volume displayed, although is the same, this contains less mass in this volume. The water contains less mass, and this sphere contains more mass. So the weight of the sphere is higher than the weight of the water displaced. So it moves downward. A resistant force of downward is created. For example, if this sphere, if this cylinder, and for example, if the cylinder were to come up, basically its density would have to be lower than water. So that is the only reason it would come up. So that is a neat thing that you probably already know, that density, the object that comes up the water have a density lower than water, but now you know it's mathematically, basically, right? Now all these equations, this equation, for example, could be a little bit overwhelming. And I suggest that if you don't understand this, watch this video again and really understand how it works. And I'll see you in the past paper sessions where we'll be tackling this equation a lot. So the concept will be even more clearer, right? So basically just memorize all these definitions and watch this again if you have. And finally, I hope you enjoyed and learned something, and goodbye.